Okay, so here's example number 2 involving the Boyle's law, the pressure versus volume relationship. So again, one time, actually, I'm going to say it every single time we do a video involving any of these laws. So pressure and volume are inversely proportional, which means that they are opposites. So as the pressure goes up, the volume goes down, and vice versa. So let's take a look at this example problem. A sample of carbon dioxide gas has a pressure of 5.65 atmospheres in a 125 milliliter flask. The sample is transferred to a new flask where it has a pressure of 6.99 atmospheres. So what has changed in this one is the pressure. Last time we changed the volume. And now it asks for what's the new volume. So the process behind these, you'll notice I use the exact same method no matter what type of problem I'm going to solve. The first thing I'm going to do, okay, so the first thing I want to do is I want to write my formula. So I'm actually going to write it in this time as opposed to animate it to try and speed up the process a little bit. So I've got P1 over P2 equals V2 over V1. Again, so last time I listed it off. If that helps you identify where everything is, feel free, list it all off. So on this example, I'll do that. My P1 is the first pressure that's listed, which is going to be the 5.65 ATMs. My second pressure is right here, 6.99 P2. My V1 is going to be the volume that went with the 5.65, which is 125 milliliters. And then there's my V2. My V2 is what I'm solving for because it says what is the volume. So that's my question mark. So now I plug it into my formula. 5.65 over 6.99 equals V2, because that's what I'm solving for, over 125. Now, a little bit different from solutions, and I just want to point out this fact, is it doesn't really matter what units your volume or your pressures are in, as long as they're the same unit. So notice that pressure was given in atmospheres both times. That's fine, as long as they're both the same. Same thing here. This was given in milliliters. It says what is the volume, so my answer will come out in milliliters. If the volume said what is the volume in liters, then I would have to do a conversion at the end because I'm given milliliters. But we'll tackle those examples as they come up. Okay, so I'm going to pull up my handy dandy calculator. I'm going to darken my screen a little bit. There we go. Okay, so I'm going to plug it in. Again, I'm going to cross multiply. Top left by the bottom right. So 5.65 times 125. Enter. Divided by the thing connected to my variable, which in this case is 6.99. So I'm going to go divided by 6.99. 2 nines. There we go. Equals 101. And I'm going to stop there because remember, I start counting with the first non-zero and I write down 3 digits. So my first non-zero is that first 1. So I'm going to write 101. So my V2 equals 101 milliliters. And then, just like the previous example, I say to myself, does this answer make sense? Okay, well, let's look at this. What happened to my pressure? My pressure started at 5.65 and it went up to 6.99. That's a rise in pressure, an increase in pressure. Pressure and volume are inversely proportional, so as the pressure goes up, my volume goes down. I started with 125, I ended at 101. That means it went down. That means my answer makes sense, so that must be the correct answer.